Section 4.6, which knows 27, use congruent triangles. The essential question is, how do you prove parts of triangles congruent? And to prove the parts of triangles that are congruent is to first prove the triangles are congruent, and then the next step is to use CP/CTC to prove any parts congruent. Okay, the CP/CTC, congruent parts of congruent triangles are congruent, and where that comes from is an acronym that has the CP/CTC is the first of every one of the statements, and that's where the acronym comes from. One of the special notes is right here that says that you use CP/CTC is used to prove any pieces of a triangle being congruent, but you must always have the second note is that your step must have the triangles are congruent first. Alright, on the examples here it says, how can you use the given information in the congruent triangles to prove the statement? It's saying, okay, if we know that AB is parallel to DE as our given, this is not actually having you write a proof, it wants you just to explain what you would do. In this, because you have parallel lines, that means this side is parallel to this side. We have a transversal that is cutting through here, which means angle B is congruent to angle E. And realize I also have a transversal cutting through in this fashion, which tells me that angle A is congruent to angle D, and it's saying here C is the midpoint of BE. We're trying to prove that. If we know that two angles are congruent, and we knowing that the triangles are congruent to each other, that means that this side CB will actually be congruent to CE, and since those are congruent pieces, that means that C, since this is in the middle, this is definition of a midpoint, C is the midpoint of BE. Okay. On the second one, it says use the given information to write a plan to prove it. It shows that angle 1 and 2 are congruent. They have double marks down here. And then 3 and 4 are congruent. So we're trying to prove that triangle DEF, this little triangle down here, is going to be congruent to DCB, which is this little triangle up here at the top. Okay, in doing so, let's see here. If I know that two sides, if I look at my larger triangles here, and then this triangle up here, they have a common side of AD.
Teachers, if you have duty today, I need you to, on the patio, I need you to report to the large gym. Again, if you are on duty this morning on the patio, I need you in the large gym. Thank you.
So I can say that AD is congruent to AD because it's reflexive, and since I know that that's angle, angle, and side, so I'd say that triangle I'm going to say ADC is congruent to triangle ADE, and that reason would be angle, angle, side that I have here. And since I have that, I know that now, here's my proving of triangles congruent. I can say now by pieces that CD is congruent, this side here is congruent to this side here because it's part of a triangle, and that would be the CP/CTC because it's part of the two triangles. I know those are congruent to each other. And if I know those parts are congruent, I also have that this angle and this angle here are congruent to each other by vertical angles. So I could say angle BDC is congruent to angle FDE, and that's by vertical angles being congruent. And then I can justify it by saying that triangles DEF is congruent to triangle DCB because I have an angle, a side, and an angle in each one of my triangles, and that would be angle, side, angle. Okay, this is not written in an actual proof or actual two-column proof. It just says plan for the proof. So I would first have to prove these sides reflexive, the big triangle is congruent, and want that part, I can say the pieces are congruent to each other by CPCTC. Vertical angles and then triangles are congruent. Okay. On number 3, it's once again just trying to prove the plan that you can actually see. You given two pieces are being congruent, which they have marked in their picture over here, and that's what's in our given. I have to come up with another piece, which for here I'm going to say that these angles here are congruent. So I'm going to say that ABF is going to be congruent to angle EBC, and I'm just going to justify that by saying that that is the vertical angles congruent. Once I know this information, then I can say the large triangles. I'm going to say ABF is congruent to triangle EBC, and by this one I see that I have a side, an angle, and a side, so I'd say that's by side, angle, side. And once I have that stated, then I can say any piece of that triangles are congruent by CPCTC. So what I'm trying to prove is that this segment in the center, BG, is congruent, G, is congruent to BD, and that would be CPCTC verification. So this is writing a proof without being so formal. Here is your independent practice problem. I want you to try to prove this one. Given all of the information that is given to you, you're just trying to actually prove the triangles congruent, not any pieces. So this should end in a SSS, SAS, ASA, AAS, or an HL, HA, or an LA, or LL, sorry, no HA. And make sure you answer your summary at the bottom.